analytic linkages. Correct, no? So for the first one, XYZ, it is Cartesian coordinate, it is LLL. The cylindrical, there will be 2 linear and 1 rotational. Correct, no? So that it is called LRL, and its work envelope generated will be cylindrical structure. So that it is called cylindrical coordinate robot. Regarding the working and all, I will be repeating once again. Another one, the spherical or polar coordinate system, which will be having LRR, 1 linear, 2 rotational. Remember in the similar sequence. And the work volume generated will be a segment of a sphere. Correct, no? And since they involve 2 rotational, it can able to do any complicated jobs like pick and place to the painting and the welding operations. Correct, no? And doing welding, you may think that it is very simple one, but once after you get into the welding, you will come to know it has to hold the torch, and the welding rod or welding, the electrode has to be maintained at least of 2 to 3 mm distance from the base material, so that a continuous arc will be generated. A uniform melting of the material takes place, and the robot welded joints, if you see, just like it is a machined surface, so neat job it is. Already those robots will be taught for this particular function. Understood? So it will be trained many times, and wherever it is required, again it will be repeated, and once again it will be taught, so that continuously for a robot to do one particular job, it may take many hours together to teach the robot. Correct? It will be other part of it. The last one is articulated or a SCARA robot. Articulated or a SCARA robot, it resembles to the human arm. It will be having 3 rotational, low linear, 0L and RRR. Correct, no? And the shape generated or the work volume generated by these robots will be doesn't have any different shape, because all are rotational, and it will be complicated to define the space, so that it can able to do any kind of jobs like the machine vision application and all these it can able to perform. Correct? And application I told you the first one, pick and place, machine loading and unloading, the cylindrical pick and place, machine loading and unloading, simple welding and simple painting operation. The third one, including these 2, pick and place, machine loading and unloading. The third one, it can able to do any complicated welding and the painting operations. The last one, it can do whatever it is. The last one it cannot do, other robots cannot do. Correct, no? So these are the 4 important configurations. I have taken a lot of time to explain many times. I want you to remember it because it is very, very important. Okay? Now, robot joints and the links. Please do not get confused. This is the link. This is the other link. These 2 links will be joined by a joint. There is no complication. And this is the robot hand, if you say, it is fixed to the base, and the joint one which is fixed at the base will be 0th joint, the first joint, second joint, third joint, fourth joint, like that. The link will be counted from the base. First link, second link, third link, fourth link, fifth link, like this. You understand? So again, I don't want to talk about the DH criteria, it is not required. The DH criteria is very important, the important one. Just I wanted to show it to you. It's not there for your syllabus. You can see this, just I put the star mark and some symbols. If you happen to go through the book in future, you can see that this is called a homogeneous transformation matrix given by the DH, diameter Nelson. And this word 3 to 3 matrix will be a rotation matrix. This matrix will be defining the rotation about the x direction, rotation about the y direction, rotation about the z direction. And this particular, this one will be showing you it is global scaling. Global scaling. Global scaling in the sense, just you take a balloon, put there, it will be uniformly increasing. And this is called local scaling. Local scaling is I want to scale only along the x direction, not along the any directions. Like that. And this px, py, pz will be indicating the position of a point in the space. If I have taken this particular point, the position of this point with respect to base along the x, y, and z direction. And this is called as perspective positioning. Perspective positioning in the sense, if you look at any bus or something, you take a photo, you can see that one will be having interest to hear this, so that I have taken. You can see that bus appears like this. In the front, correct? No? It will be smaller and larger at the front and smaller at the back side. And this particular local point, in imaginary local point, all these will be diverging and locating at this point. This is called perspective positioning. Perspective positioning, why it will be taken? When you are going to take the robot, see anything is coming on the conveyor, the robot has to recognize the position of it and what is the size of it. You can see that a person is coming around 200 meters away from my position, he looks smaller. The same person if come near to me, he will be looking bigger. But the robot should not get confused. A person is smaller or bigger. With respect to the distance also, it can able to accurately trace the height of the person or height of the object. You understand my point? The perspective should not, it should be taken into account. Just like a human being. It has to appear or it has to behave. So this perspective positioning also will be taken. And this is one of the interesting topic. You can see the maker. And other the calibration of camera. Just like a blind person is carrying a child will be directing the blind person. Go left, go right, like that. In the similar way, when you take a new camera and you want to make it as a part of the robot, it has to be calibrated. The calibration is also very important. You know, if you come across in future, try to go through all this, so that today you can remember it when you are going to learn those things later. And the linkages and the joints will be numbered from the base. The linkage is an open link kinematic mechanism of the robot. It is called manipulator. The manipulator will be made out of so many linkages and joints. The joints will be connecting the two links together. Correct? No? The joint will be connecting two links together, and the link which will be starting from the base will be taken from 0. And the joint which will be at the base will be taken 0. So this is the robot hand 0 joint, first joint, second joint, third joint, fourth joint, like that. First link, second link, third link, fourth link, like this. You can see that numbering of links and the numbering of joints. Nothing more to write in this. What is a link? Link is a mechanical rigid component of the robot. It is a part of a manipulator. And these links will be connected together, make a series of open link chain by means of a joints. Joints may be rounded joint or it may be a prismatic joint. The prismatic joint is a telescopic joint. It can only extend and come back. It's not rotate. Correct? No? If you have the joint like this, you can see this. It can be slided front and back, but I cannot rotate it. It is not possible to rotate. It is called prismatic joint. Correct? No? Just a prismatic joint. And I don't want to write these 3D figures. I want you to understand the concept. Okay. And now let me come to the joints next. I told you the joints may be rotational or prismatic. Combining these, they have made 5 different joints. How? The first one you say linear joint. Linear is a prismatic. Linear is a prismatic. It can be along with the axis of the initial joint. This joint is there. Please look here. This is the initial joint. The joint will be having the same axis as that of the second one. The same thing I am writing here. Please look. The same thing I am writing here. I am writing the same. Okay. This is the second one. This is the second one. This is the first one. These are the two links. And they are linearly correlated with respect to the input link and the output link. What is the input link? This is the input link and this is the output link. Correct, no? Output link. So the input link and output link are linearly moving, so that it is called linear joint. Linear joint. Very simple, just like in Cartesian coordinate system, we will be using these linear joints. The second one is orthogonal joint. It is also linear joint. Please do not get confused. It is also linear joint. Only the difference is the output link will be having the axis perpendicular to the input link. That's all. Now this is the input link and this will be the output link. Output link. Understand? Only what it was matching is earlier we are taking this was telescopic action. The linear joint was having the telescopic action. The orthogonal joint will be having perpendicular, just like I am going to attach something here. Attaching just like this. Okay? Okay. Like this. It is sliding in this, but output will be taken from this. It may be having some joint or somewhere will be connecting it. The input link and output link are perpendicular to each other. That's all. You understand? Output link and input link will be perpendicular to each other. I don't want to write this. What you have to write? Please look here, the same thing I am writing. This one, input link, the output link is this. Output link, input link. Of course, it will be sliding like this. The positioning will be taken in this direction. That's all. It is orthogonal. Orthogonal in the sense, it is perpendicular to the. The next one is rotational or revolute joint. Rotational. It is a prismatic or what this joint? Revolute joint. Rotational. Correct? No? Rotational joint. It will be rotational. And here also, the relative motion between the input and link, output link will be perpendicular to each other. You can see this here. Once again, I will be showing. You can see this. This is the input link. This is the output link. It will be rotating, just like this. This particular joint will be rotating. Okay, or you can say here only okay. This will be rotating in this direction. The axis of rotation will be perpendicular to the input link. That is the orthogonal joint. This one, no, it is linear movement. It cannot rotate it. It cannot rotate it. But here it can be rotated. Understood? It can be rotated. So this is how I am going to show. You can see here. You can see that. It can be rotated. This is the second link. This is the first link. Link 1 and these are the link 2. Link. And the joint will be rotation. Joint will be rotation. It can rotate like this. That is the rotational joint. It is called rotational joint. The last one, twisting joint. You take cloth, put in water, you are applying tension or a torque to remove the water. One will be holding that side, other will be holding this side. You are going to apply the tension and you are going to apply the twist. You are going to apply the twist. Both will be in the opposite direction, correct? No? So that the water will be removed from the plant. Here you can see that twisting is twisting will be like this. You can see here the twisting joint. That's all. This is the input link, and this is the output link. Output. You have seen some other floor mill and all. A shaft will be very bigger than that. That time I am not getting the shaft of similar length. What I am going to do? I am coupling 2 to 3 different shafts together. So once you couple them, what happens? You are going to apply the load. It will be rotated. It is a twisting rotation. Twisting. Why it is called twisting? Why it is called twisting? That always the output link will be opposite the rotation of the input link. Correct or not? Opposite, because of so many other elements in there. As soon as I put just a small pressure, the bus will start to run. Bus is standing. Correct or? So many people are sitting inside the bus. And a single person is enough to push the bus. So many people record because initially high torque will be there. Once it gets inertia, a single person is enough. Correct or not? Once it starts to run, once it is the bus is pushed and start to rotate, what happens when wheel started to rotate? 2 to 3 people or 1 person also can be enough because it will be having the inertia, the lot much more opposite torque acting on the inertia. The initial torque will be more. So that here you can see this, the input and the output. These two will be coupled together. Once it is rotated, this will be rotated. It is a twisting. Twisting. You can see this is a twisting. Correct? No? It is a twisting. Twisting. Correct? No? One will be rotating in the opposite direction, other will be rotating in this direction. Twisting. Twisting. And then one is revolute joint. Revolute joint. What is the meaning of revolute joint? You can see here. It is a revolute joint. This is the input shaft and this can rotate. This can rotate. This dash can rotate in this. Correct? That is called revolute joint. And if you want, you can write that figure only. You can write. Okay? A small stick-like structure is that one. Other one is this. And if you want, you can add up other one also. It will be a flange. You can see. Okay? This is this one. And this is other one. And this is this one. And this is this. So this can be rotated. It is a revolute joint. Revolving joint. So please try to. One of your friends have written 4-stroke petrol engine, single-stroke petrol engine, 2-stroke petrol engine, 3-stroke petrol engine, and the 4-stroke petrol engine. In the computer to write section stroke, compression stroke, expansion stroke, and the exhaust stroke. What I want you to remember, during the section stroke, the pressure difference will be there. Due to this, the fresh air will be taken inside the engine cylinder in diesel engine. Air and petrol will be taken into the engine cylinder with the petrol engine. At the end of the stroke, both inlet and exhaust will be closed. The piston will be moving top or bottom to the top. So due to this, the charge taken will be compressed. In case of petrol engine, it will be compressed up to 1:15. At the end of the stroke, the spark will be developed. It starts to ignite. Due to the ignition, the burnt gases will be expanded. So due to this, there will be high pressure of the combustion product. Due to this, forcibly the piston will be moved down. It will be called as power stroke. In case of diesel engine, at the end of the stroke, the air which is compressed will be attained a temperature more than the ignition temperature of the diesel oil. As soon the diesel oil is sprayed in a atomized form by means of fuel injector in the combustion chamber, it starts at the fire. And it will be moving down the piston, that is called power stroke. But none of you have written, very few of you have written, who they have got more than 17, 16. I want you to come and see that where you can improve yourself in the examination. It's not like